So we're continuing with application software. So we already looked at the system software. Now we're at application software. So we already looked at the application software. It's basically being used for carrying out a specific task, right? So what are the types of application software? We have general purpose software. Now these software are basically open to the general public. So whether you're an organization or business, basically anybody can use it, and it doesn't depend upon a specific business or organization. Not that it's not limited to any business or organization. Anyone can be able to use it. So for example, a word processor, database, spreadsheet, presentation, drawing or painting application, you are free to use those applications. Doesn't matter who you are. Now, AC is very high. Nicholas is equal to what?
Let me actually actual.
Yes, that's much better. So, general purpose, anyone is allowed to use it. Now, the customized and the custom written software, these are software that are basically customized, as the word implies. You take the generalized software, so say for instance, you take Microsoft Excel, you take Microsoft Word, and a company modifies it, customizes it for their purpose. So maybe they want to add in some sort of special feature, so they modify it, they customize it, and they add in their feature, and they use it for their particular purpose. So that is the customized software or custom written software. So the custom written software now, also called bespoke or tailor-made software, it is used by a specific organization. So for example, the military, hospitals, banks, financial institutions, they would have their particular software that they're carrying out the task. Like for example, a weather station, they have a software that's monitoring all the weather data. And do we have access to that software? No, we don't. So it's only limited to that particular organization. So that is the custom written software. So customized software, you take a general purpose software and you modify it for what purpose you want it to do. The custom written is basically like you're making it from scratch, and you make it according to what you want it to be. Are we clear on that? So what are some examples? We have software that are used in air traffic control, so the software that monitors how the plane moves and so on. Accounting software, airline reservation software, computer aided software. Those are not general purpose. They require basically a specific type of person, a person that is operating a specific type of job in order to use this particular software. So basically, it's like you gotta specialize in the software. You gotta be trained in order to use the software. Because a general purpose software, how it is developed, any person can go and pick it up and be able to use it. But the specialized software, the custom written software, you have to be trained in order to use the software, because it's gonna be different from the regular software. Then we have specialized software. This one is written solely for a specific task rather than a range of function. So a software that is developed for a specific task. Now compare specialized and general purpose. General purpose, not only can the general public use it, but you can also use it for any purpose that you want to use it for. For example, A word processor. What can you use it for? Creating documents. You can use it for create good. You can use it for make a letter. You can use it to create a poster. You can use it to make a table, diagrams, different purposes, right? So you use it for what you want to use it for. What? So, but for example, now a specialized software, a camera app, you can only use it for that particular task. It was designed for taking photos, and that's basically it. You can't view the gallery, you can't edit the pictures. It was only designed for taking the pictures. So, general purpose software, the general public can use it. You can use it for whatever purpose you want to use it for. Whereas specialized, it was developed for a particular function. Your camera app, a game, it was only developed to play that game. You can't do anything else with it. So it's specialized software. Hmm? Then yeah, that's that. But are you going to use the that game now only for communication? Good. Are we clear on the 4 types of application software? General purpose, customized, custom written, and specialized. Giovanni, we there? Integrated software, Art 5. So this is what I was talking about earlier. Integrated software or software package is basically grouping multiple softwares into one. So a company would do this. So like for example, Microsoft Office is a package of software. Adobe has a package also. So Photoshop, Premiere, and all the other software, Afterworks, and so on. Now, notice here, it says that it's not a true integrated software because the programs are still separate. You can basically still install Microsoft Word on its own. You can install Spreadsheet on its own and only have that on your system. So it's an integrated software, but not a true one because they don't depend upon the others. They're not installed, not necessary for you to install it with the rest.
Could the launcher be defined as an integrated software?
Packaging other applications?
Yeah,
You could say so.
a launcher. I remember like Minecraft, all the different versions of the launcher.
Minecraft for what?
No, because Minecraft has like all the different versions there in one software.
Good, so
Minecraft for what?
now what he's saying for integrated software, remember you're packaging all into
No, sir,
one.
continue.
So what he's saying, like if you group various versions of a particular software into one package, then that will be integrated.
No, sir.
Okay, sir. So it's basically a group of versions.
But that won't be applicable though to group versions together because remember you always want the updated version.
Exactly.
So it's more of different.
Exactly.
If they got like a private humanity upgraded version, they can move back to that older one.
I don't like
Yeah, but
Microsoft.
people don't really do that though.
Who use them,
It's
Fred?
like
Linux.
Windows 11.
All right,
I mean Microsoft Office.
Kia,
That's right.
we're recording.
Yeah. Might be a question.
So we have categories of software now. You have to remember what's the category of software or what's the type of the software and what are the examples. So we have word processing softwares. These are software that allow you to edit a document, type your letters, and so on. Microsoft Word, Google Doc. We have desktop publishing, which allows you to create newsletters, leaflets, posters, and so on. Microsoft Publisher, Google Slides. Database software, Microsoft Access allows you to create a database to store and sort your data. We have spreadsheet types of software, which allows you to do financing, allows you to do budget, create models, forecasting, and so on. You have Microsoft Excel, Google Sheets, those are examples. Graphic software, these allow you to paint, draw, and so on. So Microsoft Paint, Photoshop, and so on. Computer aided design, this allows you to detail plans, models in 3D, So examples: AutoCAD, DesignCAD, and so on. Good afternoon. Integrated software. We already mentioned Microsoft Office, Adobe. What this does is that all major application programs which are closely related, and the output for the various programs can be transferred, embedded into each other. And then lastly, you have presentation software, which allows you to create a presentation, basically Microsoft PowerPoint, Prezi, and so on. Good. Are we clear on the types of software?
Yup.
As you shouldn't be.
As you should.
So, as a recap for just that joined us, we have 5 types of software. General purpose. Anyone can use it. It's open to the public, and you can determine what you're going to use it for. Your PowerPoint, your spreadsheet, your Paint, and so on. Customize. You take a general purpose software and you modify it to however you want it to work, right? Custom written. You build your application, your program, however you want it to work. Specialize basically refers to a software that that is going to only carry out a particular task. And integrated, basically a group of software. User interfaces now. A user interface is basically how you interact with the system. A user interface is basically how you interact with a system. So we have computer user interface, which is also known as a human computer interface. So, for example, when you are using your phone, how do you interact with your phone?
Touch.
The touch screen, right? When you're using your laptop,
Trackpad, keyboard.
the trackpad, keyboard, and those things, right? So that's how you interact with the system. So that is the user interface, how you interact with the system. Now, let's see. What's an example of that?
Of what?
Of course, sir.
If you're using Amazon Echo,
So it's not the speaker thing. That's what is that the speaker thing?
yeah,
In a environment.
yeah. If you're using Alexa, so how are you interacting with it? Voice, right? So that's the user interface. That's how you interacting with the system. You're using voice in order to interact with it. Now, what are the points to make interface effective? 1, it must be attractive. 2, it must be simple. Must have a quick response time. It must be easy to understand, and it must be consistent. So, attractive, you look at it, you're comfortable with using it, simple to use. When you touch something, when you click on something, it's the action happens right away. The instructions easy to read, so it's easy for you to learn how to use it. And the layout is consistent. What that means is that when you go on different pages, the layout is still the same. Like when you go on a website, don't the tabs at the top stay the same?
Yes, sir.
So that's what's meant there. The layout remains the same, or remains similar to what was before. So our first type of interface is called the hardware interface. We know what hardware is, right? The physical parts of our computer. So, permanent. So, interface is how you interact with the system. Hardware is the physical components. So, hardware interfaces refer to the physical components that you use to interact with a system. So, examples of that. Where did Yeah. So hardware interfaces, you have touch screens, sensors, digital cameras, special keyboards, um, buttons, touchpad, joystick, hand grips. So anything that you're physically touching to carry out some sort of action on the system, that is your hardware interface. Are we clear on that?
Yes, sir.
Software interfaces now. So you're playing a game. How do you interface with the game? How do you interact with the game?
Keyboard, mouse, joystick, PS5.
So if you're playing on a computer, a keyboard and a mouse, right?
Yes, sir.
Good. So if you're playing on your PS5, you're playing on your PS4, using a gamepad, right? Or game controller. So that's your good. So that's your method of interacting with the system. Now, we have software interfaces, which is what we use to interact with the system. So, for example, like I mentioned, when you're using Amazon Alexa, you would say something to the system, and that is your method of interacting with the system. So, for software, we have 4 types of software interface. We have command line, menu driven, and graphical user interface. The command line interface is basically what you're seeing here. It's a text-based interface. All you're getting is text. All you're going to see is characters. So, for this interface, you actually have to learn the commands. You have to learn what's the rule of the language, basically. So if you don't know what are the commands you have to enter, you won't be able to use this interface. So, because you have to learn how to use this interface, we moved away from it because it's not user-friendly. If you were to get a computer that started up like this here, if your computer started up like that, would you want to use it? Huh?
Oh, type in slash.
Um, Would you know how to use it?
Slash MSG. Slash MSG.
Good. So that's the command line interface. You have to learn a set of commands in order to use it. Now the menu-driven interface basically gives you a menu where you're going to select what is on the menu. So for example, this here is a menu interface. You see a bunch of menu options and you can select what you basically want. You don't have to type in what you want. You ever notice at KFC and Popeyes, how do they enter your order? They touching the screen, right?
Yeah.
And you ever look at the screen where they're touching?
Yeah.
You can. Some of them got to decide. So what is beyond the screen is the actual images of the chicken. The actual image of the chicken parts and the drinks and everything for the menus be on the screen there. So all the person got to do is select each piece you want, select what drink you want, and then it can come up what's the quantity, and they just select that, and it tallies up everything for you. So menu, huh? Because I saw it.
Man get access to the island food.
No, some of them will turn on the side and you can see it. Oh yeah. When they had the lockdown, y'all never went to the churches at Camp Street. No, the churches at Camp Street. Yeah, when you have to line up outside, you had a window, and when you actually look in the window, you'd actually see what happened on the computer screen.
Oh.
And if you ever go Demico, you can see it at Demico too. Good. Now the menu, you have to know what you have to select in order to. So for example, also ATM machine. Any of you ever use the ATM machine? So your parents use the ATM machine? It's a bunch of menu options, right? So you touch the screen, you see the menu option, you select it, and the action is carried out. Now, a graphical user interface is making things more user-friendly, making things more simple, so that persons can interact with the system. The graphical user interface is made up of an acronym called WIMP, which stands for Windows, Icons, Menus, and Pointers. These 4 points is what makes up a graphical user interface. Each one is going to have windows. So as you can see here, there's a window. This is a window. Icons, if you look at the bottom of my taskbar, those are icons there. Menus, if you click anywhere at the top here, you have some menu options. And then pointer, you have your cursor which you use to point. So those 4 make up the graphical user interface. Alright, so I just showed you was a window. I just showed you what are icons. We already know it's a menu, right? Oh, we have types of menus though. We have a pull-down menu and we have a drop-down menu. So, it's as the name implies. Pull-down would mean that you click on something and the menu basically comes down in that location. So, that will be pull-down. No, not drop-down. Pop-up. So, it's pull-down and pop-up. A pop-up menu, pop-up anywhere. Pops up anywhere. So that's when you right click. You right click at the top, it pops up there. Right click at the bottom here, a menu pops up. You right click in the document, another menu pops up basically. So a pop-up menu, the menu pops up anywhere when you right click. And a drop down menu is when the menu drops down from wherever the menu is already located. So within the let me go to the desktop. So even within the pop-up, you can get a drop-down. So notice this is the pop-up and a drop-down. So the pop-up is the right-click, the menu pops up. But the drop-down now is when I go in View, and that menu drops down. Alright, so pointers, this is what basically used to point to indicate where you're navigating, where you want to interact with the system. And how do we improve the user interface now? Now, one thing that we need to ensure for a user interface is that it works exactly the same way each time the person opens the software, each time the person opens the website, each time the person plays a game. The interface must be the same way. For example, you ever played a game and then you conquer the game, so you're comfortable with the interface, but then part 2 comes out and the interface is totally different from the part 1.
Yes, sir.
How did you play that game? You still played it?
Yes.
But did you enjoy it?
Yes.
At first, did you enjoy it?
No, but
But eventually you got accustomed to it, right? But at first, it was a little difficult, it was a little annoying and so on, right? Good. So, that there is a tip for creating a good user interface. It must be the same as was previous, or try to be as similar as possible. It must be visually pleasing and soothing. Remember, the person has to be looking at it all the time. So the color mustn't be too bright. The color mustn't be too dull. Must be just right. The design must be just right. Everything must be just right. And we also always have to be catering for impaired persons. Persons with disability, they can't see well, they can't hear well, they can't smell well.
Smell well.
Any questions so far? Types of computers now. Yeah. So, depending on the need, you will use different types of computers. If you want to create a PowerPoint, use a desktop or a laptop. If you want to control traffic lights, you use a smaller computer called an embedded system. If you want to send a computer to Mars, use another specialized computer. So depending on the need, you would use different forms of computers. Now, a question that could be asked in your paper is, what should you look at, or what needs should you look at when you are selecting a computer? So when you're selecting a computer, what hardware does the computer need? What input devices does it need to carry out what tasks you want to do? So let's say you want to record music. What input device would you need? A microphone, right?
Yeah.
Good. Then you got to determine how much storage do you need. Am I downloading a lot of movies? Am I downloading a lot of games? Then I need large storage. But if I'm just using the computer to browse the internet, I don't need a lot of storage. And then what do I need as output? Do I need to print something? Do I need to see something large so that I got to put it on a projector? Those questions you ask yourself. Then what software do you need? What are the tasks do I have to carry out? So what software do I need? Am I creating a PowerPoint? So I gotta get a PowerPoint software. Am I going to be creating house plans? So I gotta get an AutoCAD software. Those questions you ask. So what software? What data are you going to process? How are you going to interact with the system? What's the user interface for the system? Who are going to use the system? What work they're going to do? What data they require to put into the system? So for example, once again, they need to put in voice data. So you know you need a microphone. You know that they want to put documents into the computer. They want to put, you're a photographer and you want to transfer images to the computer. So you need a scanner. So those questions you would ask yourself. Are we clear on all this? Good. So now what are the types of computers? Now, the largest of computer, not sure why this textbook doesn't have it. The largest of the largest computer. What is it? A supercomputer. A supercomputer is the largest computer, the most powerful computer that you can have. Yeah? The mainframe is fast, but the supercomputer is the fastest. And the largest, yeah.
The server is.
It's much larger than a server.
Wow.
So, like for example, NASA, they would make use of it.
Oh.
No, not the satellite.
He's like, can I tell you though?
It's kind of like a,
Fridge.
it's kind of like a server, but it's kind of like you're setting up a server, but this here is a server. But if you notice, you have more of them. So what they do, they combine multiple servers together. Basically, combine more computers together, and we get what is called a supercomputer, or multiple servers, basically. Or even a supercomputer could actually be created by joining everybody's laptop. That was actually no, I said it's a possibility. So there was actually to process a lot of data, we can actually use the processing power from all the computers in the world, and that can actually function as a supercomputer. So you could give your laptop a piece of data to process, somebody else's laptop piece of data, and everybody now combines and send their data together, and that can function as a supercomputer. But then persons won't contribute to that, so hence persons develop their own. Now, under the supercomputer is what you're going to have a server. Not sure why the textbook doesn't mention that either, because a server is actually larger than a mainframe. No. It's kind of like a mainframe is kind of like a server, but is it? No, it's a mini computer. Let me confirm this. I'm confusing it with mini computer. Mainframe. Mainframe should be server. Mainframe computer. Yeah. Mainframes are basically servers. So these are large computers that are going to be used to serve a lot of smaller computers. They're going to have more power supplies, more hard drives, more CPU, more storage, more processing, and so on, so that it can carry out more processing, more output, input, and so on. Desktop computers, this is what you're going to use for personal use. That's why they call personal computers, PC. So they're going to have smaller storage, they're going to have slower processing power, but it's just enough for what you need to carry out your tasks. Mobile devices. Mobile devices refer to any device that basically has a battery inside of it. So it's portable. So a laptop, a notebook, netbook, tablet, smartphone, e-reader, game console, your Nintendo Switch, those are all portable devices. So they're smaller, lighter, they contain batteries, and you can take them wherever you want. So they're portable. Now the embedded systems. These are dedicated computer systems designed for one or two specific functions. So there's design for a specific function. You have your laptop, you got your desktop. It's not as powerful as a server, but you can use it for whatever you want. You can use it to play a movie, play a game, browse the internet, do whatever you want with it. But the embedded system now, it's only created for a particular task. Like for example, the traffic lights. It's only created to operate the traffic lights. The embedded system that is in a smart fridge is only created to monitor the items in the fridge and process that. So, y'all stop it with the Rubik's Cube. They consume very little processing power. They may not be connected to the internet because they don't need connection to the internet. Like for example, if you have a washing machine that has it, but then we enter in a phase, but it's, if you notice, it says may not. But today, most of them can't have connection to the internet. Like for example, a smart fridge, you can have connection to the internet, so when you go to the supermarket, you can check the app and see what items in your fridge. You didn't know that was possible? That's possible. They got fridges like that already out. TVs like that and so on. So embedded systems include digital watches, so your smartwatch, your printer, your washing machine, ATM machine, four-wheel drive vehicles, traffic lights. So the computer inside a Tesla, an embedded system. Good. Are we clear on the types of computers? So the questions you might have to ask yourself or in the exam is they might ask you, they might give you a scenario, you have to select what is the most suitable computer for that task. So if it needs a lot of processing power, it needs a lot of storage, it needs a lot of basically a lot of storage, a lot of processing, a server might be what is needed. But when I say a lot, I mean a lot. But if you know it's an everyday task, like watching a movie, editing pictures and documents, you know it's a desktop. But you might also see the term workstation. Y'all ever heard that word?
Workstation?
Yeah.
You can need like a PC for that.
So a workstation is like a desktop, but it's a desktop that is spec'd out. You got a lot of specs in it. You got the high-end graphics card. You got like 32, 64 gigabyte RAM. You got like 2, 4, 6, 8 terabytes of hard drive. So multiple hard drives, multiple RAMs, multiple power, not multiple power supply, but a very high-end power supply. The highest of the high-end graphics card. That's what we would call a workstation, because it's going to be created to carry out work. So for example, if you're a professional video editor, you're a professional designer, you would use a workstation because the system can handle those high-end software. Are we clear on that? So those are the types of computers. And all right, for troubleshooting,
Let's skip this.
it will come.
Oh.
Troubleshooting. In summary, the first thing you always check when you're troubleshooting something is power. That's the first thing you always check. You check if the device is plugged in, if the device is getting power. So is the cable plugged in? Is the power button turned on? That's the two main things you check first. Then after that, you have to check to see if the surge protector is on, if the power strip is on. See on? So basically everything that deals with power, you have to ensure it is on. Now, if it is a monitor, the monitor, you're not getting any feed on the monitor, you have to check cable. Everything is about cable. That's the first thing. Is the cable to the system unit, is it connected properly? Is the device turned on? Even for a mouse, why is the mouse not working? Maybe the mouse is not plugged in properly. So everything is power first. You see a red X on a battery. What does that mean?
Dead.
What is dead?
It's
It's not detecting a battery. The battery is bad. It's not detecting a battery. It's basically telling you that the battery is so bad that it cannot use it anymore if you see a red X. Printer problems. You're printing and you don't get anything on the page. What can that indicate?
I'm done.
You don't have any ink. So how do you troubleshoot that? You buy ink and you check and you test for the ink. That's simple. The paper. When you're printing, the information doesn't come out straight on the page. Align what?
Paper. Fix it.
It's coming out slightly slanted on the page.
Okay.
You need to align the printer. Every time you change the ink in the printer, sometimes the components in the printer misalign. So that's why every time you install a new cartridge, you ever notice they ask you to align the cartridge?
No.
They would ask you that. Yeah, align the print head. Yeah, align the print head. So that there will ensure that when you print it, everything comes out aligned on the page. You're printing and nothing comes out, and the printer is not making any sound or anything.
So probably off.
The printer is off.
Check the cable.
Check the cable. The printer could be off. Maybe you didn't select the right printer. You didn't select the right printer, so it's not sending to the right printer. Alright, so we finally finish with one chapter.
Sorry, so this is one topic from the broad topic.
Yeah. Yeah, fundamentals, yeah.
Let me go. Let me go. How much more
Tree.
we got to do, sir?
So what was your appeal, sir?
Alright, let me move quickly. So, is data processing a part of the topic? So I might check quickly.
Are you on quickly, sir?
So we can know if we can run, if we got to run through this here. Huh? Oh, these things always come. Any bet is on? I bet is on. I bet is on. Data pro.
Yeah, of course.
That's not on?
Yes, sir.
Yeah. But you still got to know it for paper one, either way.
But some people want to hope the best. But that's what people want to hope the best.
Alright, good. Let me just run through it quickly. Data. What is data? Data is raw facts, unprocessed facts, raw facts and figures, basically. You don't understand it. You don't know what is the true meaning. Information is processed data. So for example, I say Keelan, Robert, Michaela. Do you know what I mean?
What? You see that?
I say, I'm saying right now, Keelan, Robert, Michaela. What do I mean? People?
You call it me?
Exactly, you don't know.
You know what? Oh.
You don't know what I mean.
Oh, this is wax.
That's data.
Oh, yeah.
So you don't know if I'm talking about students from QC.
Yeah.
You don't know if I'm talking about somebody's last name or anything. So you don't know anything. He might know, but we don't know. So that's data there. It might make sense, but you don't know what the true meaning of it. You know what's 30, you know what's a name, but you don't know what the true meaning of it. Information now is when you understand it. If I say Michaela is a girl, Keelan is a boy, that's information. We know what that means. So that's the difference there. The term information system is given to any record keeping system. So it's a system that is used to record data. All right, I want us to go over validation and verification. They will come in the paper, and I want you guys to understand it. Data validation is the computerized checking of data for errors before it is processed. So you're checking the data to see if it has any errors as it is being entered, when it is being entered, so that before you go and process the data, you go and check the data to see if the right data was entered. So for example, a method, and it's important for you guys to remember all of these methods. A method of validation is called a range check. What this does, it checks a range of data. So the system would know what's the range. Like for instance, you're entering grades to students, and we know what's the range of data for grades?
1 to 100.
1 to 100. So 0% to 100%. That's the range there. So now, if somebody is to enter 200%, somebody enter 150, that's going to be wrong. The system is good because it's not within that range. So that's a range check. It's not within that range of data, so it's going to give you an error message. Are we clear on that?
Yes, sir.
A reasonableness check now. So a reasonableness check checks to see if the data makes logical sense. Like for instance, we have the example here. You're recording data on children that attend preschool. Now that's going to be children that are of age 4. But we enter that the child is 14. Does that make sense? No, a 40-year-old would not be attending preschool in most cases. So that's not reasonable. So that doesn't make sense. So is the data reasonable? Does it make sense to enter? Data type check. This should be a simple one. In database, we have data types. In spreadsheet, we have data types, right? We have text data type, we have number data type, we have the date data type. And if you have a number data type set as your entry, can you go and type in letters? No. It's going to give you an error. So that is a data type check. It checks to see if you're entering the correct data, the correct type of data. Consistency check now. This checks to see if the data you're currently entering matches what was previously entered or what you might enter in the future. Is it consistent? Is it matching up with everything? Like for instance, this example here. All right, let me not use the example because the example is confused persons. So, say for instance, a couple has no children, but they go to the government and apply for child support. Does that make sense? Is that consistent?
A couple months.
A couple has no children, they're married, they have no children, and they go to the government and apply for child support.
Oh, yeah, that makes sense.
It's fraud, right? It's not consistent, right, with the data that's been entered. So you can't not have children and at the same time you go and apply for child support. That doesn't make sense. Similarly, a person who is not employed. Everyone knows that America gives unemployment benefits, right?
Yes.
If you're not employed, they give you some benefits. They give you money. They give you money, or they might help you to get a job. Unemployment benefits or food stamps and so on. So, say you're employed, you record that you're employed, but you go and apply for unemployment benefits. Is that consistent? Did that make sense? No. So it's not consistent with the data that you're entering. You can't be employed and then go and apply for unemployment benefits. So consistency, check to see if the data matches up. Presence check. As the name implies, presence. Is it there? It's checking to see if data is there. For example, in a database, you're not supposed to leave cells empty. So it's going to give you an error if you go and miss a cell and not enter any data in that cell. Are we clear on that? Format check. This checks to see basically if you enter the data in the correct format. Like for example, when you enter in a date, some persons like to put day, month, year. Some persons like to put month, day, year. Are you following that format? When you enter in a phone number, what's the format? Am I supposed to put the 3 digits hyphen the 4 digits after? Or am I supposed to put the country code hyphen the 3 digits so that the 4 digits after? What's the format? Am I following that format? The length check. This checks to ensure that you enter the correct length of data. Like for instance, you enter in a password. You're now signing up for an account. And they say you got to enter between 8 to 12 characters. And you enter 5, it's going to give you error. Because it didn't meet the length that you prescribed. Are we clear there?
Yes, sir.
Check digits. Check digits, the extra digit added to the end of a code. So check digits, it detects errors arising from transcription. So basically, if you're sending data, and what basically happens is that it could be corrupted as it's being sent. So this digit is basically used to it's like a method of verifying that the data is still the same as it is being when it is being received by the other person. So those are all the methods of validation to ensure that when you enter the data, it is correct. You check to see if it's in the correct range, if it is reasonable, it matches the data type, if it's consistent with the rest of data, if it actually has data, it meets the correct format, it meets the correct length, and it basically is correct. Now for verification, data verification, if you notice, we have validation and verification, almost similar, yet different. It checks for mistakes such as transcription errors when data is copied from one medium or device to another. So when you're transferring data, it checks to see if the data is correct. So one method of that is called double entry. So double entry in that when you're signing up for an account, how many times do you have to enter your email? You're signing up for an account. How many times do you have to enter your email? Twice, right?
Twice.
Why?
Verification.
Verification, right? See, so they want to ensure that you know that you enter the right email. So
And the right password.
good. So by the fact that you're going to type it in twice, it confirms that you are confirming that you're actually typing it correctly. The other method of verification is a visual check. So basically looking at it and ensure that it was entered correctly. But we know human errors, we might miss something because we don't see well. Alright, so you know what's a turnaround document? Data login is a method of automatic data capture where a reading from a sensor is input at regular intervals. So when you're doing, say for instance, you're doing research, you would carry out data login. Anybody know what's microfilm? Yeah.
Sir, the thing, them printer is like a tape, things like that.
It's an older method of printing. Why am I connected to W? It's an older method of printing. It's called microfilm, or it could also be called microfiche. Yeah, F-I-C-H-E. No internet. Hold on.
What is English
Good. So this here is an example of a microfilm or a microfiche. Micro F-I-C-H-E. It's like if you're printing on a paper, but what do we normally print on a paper? We print, say, we print one set of information on the full paper. Now, what's happening here is like, think of this one page here as this one square here.
Oh.
This one page is being minimized into this small square that you see in here. And this is actually as small as this, as my hand opening here. This entire document that you see in here is as small as my hand here. So it's basically minimizing what you see in here into this small square. It's printing it on here, and then this is even smaller than what you see in here. So they actually have to use a specialized equipment to see the information, like a microscope, in order
That
to see
would
it.
like project this to make it big.
So the purpose of that now was to reduce paper, reduce the amount of paper. All right, computer networks. So what is data communication? Data communication is the transmission of data and information between two or more computers. So the transmission of data between two or more computers. What services do we get because of the internet? We have email, voicemail, fax, telecommuting, video conferencing, electronic data interchange, GPS, online services, social media. Those are all services that we get because of the internet. They might ask you questions like that. What's the benefits of the internet? Services from the internet. Good. We already know what's upload and download, right?
Yeah.
Yes, sir.
Good. There are two configurations of a connection. We have point-to-point and broadcast. Point-to-point basically has 2 points. If something is point-to-point, from one point to another point. So only two things are inside of it. So from one device to another device. Now, so it's a direct link. Now a broadcast is just like how you guys broadcast messages on WhatsApp. You go from one to many. So, what are methods of transferring data? We have microwaves, radio signals, microwaves only travel in a straight line. So the antennas, they would usually send the signal in a straight line. Well, we have different types of antennas. You guys know that, right? We have different types of antennas. Some antennas send the antenna in a send the signal in a straight line, and some would send it in an omnidirectional. So basically send it around. So when you want to send a signal at a longer distance, the antenna has to be directional. So it has to be pointing wherever you want to send the signal, and it's going to send the signal farther by pointing in that direction. But if the signal is being spread, then you can't send it. It's like you can't focus to send it in one direction. It's just going to be spreading out. So it won't cover much distance. Do you guys know your cellular network? Your phone using the phone service, the SMS. That's a network.
Yes, sir.
Good. All right. So our network configurations. We have about 4 of them. We have LAN, MAN, WAN, and PAN, and then WLAN. So from the smallest to the largest, so we have PAN being the smallest, LAN after that, MAN is after that, WAN is after that, and a WLAN is basically a connection extension of LAN. So a PAN stands for Personal Area Network. It's a personal network. So no, I won't consider hotspot nor data. Bluetooth. You're creating a personal connection between your device and another device. Your phone and a printer, your phone and a speaker, yeah.
Wi-Fi direct, that would be a PAN.
Yeah, that would be a PAN because it's between 2 devices, right? So once it's between 2 devices or a small number of devices, it's a personal area network. Now, why I won't say a hotspot? Because a hotspot kind of connects a lot of devices. Some connect 8, some connect 16, and that's kind of like entering the realm of a local area network. Because a local area network is a network that you're going to have in a room, a building, from the smallest point from a room all the way to the entire building. That's a local area network. So if you connect everything in a building, that is a local area network. So it's nearby basically. Are we clear so far?
Yes, sir.
Then we have Yeah, so after the LAN, you have a MAN. Now, MAN stands for Metropolitan Area Network. Now, huh? Metropolitan Area Network. Metropolitan. So, a metropolitan is larger than a LAN. It's basically like you're connecting multiple LANs together. Remember, a network is basically connecting devices, right? So, a PAN, you're connecting two devices. Local area network, you're connecting more devices in a building. And then when you want to communicate with another building, like you want to communicate with QC, you set up a network to that school there, and that would be a metropolitan. We're entering the realm of a metropolitan area network, because metropolitan is going to start from connecting buildings together. So when you start connecting multiple buildings together, you get into the realm of metropolitan. So, you ever went to UG and saw how many large buildings they have?
Yes, sir.
And you know some universities got some large campuses with large buildings? So each building is going to be a local area network. And when you connect all of those local area networks together, you get a metropolitan. So metropolitan starts from that size all the way to a couple kilometers. So 5 kilometer all the way to 50 kilometer. That's the size of a metropolitan. So when we were measuring this here, that's roughly the size of region 4. So you can see if the entire region 4 was connected, or even all the houses in Georgetown were connected, that's a metropolitan area network. But when you go past that now, say you go past, you start connecting the regions in Guyana, you're entering the realm now of a wide area network. So you connect the regions, and then more so you connect all the countries together, you have a wide area network, which is the largest network. And the most famous example of a WAN,
World Wide Web.
the most famous example of a WAN network, the Internet. The Internet is the largest wide area network. You guys know that that's basically the Internet, right? All devices in the world basically being connected to each other.
Sorry, it's like
Huh?
Nobody.
No one.
It's like who made it?
It was just, I think it was Bell Labs.
Yeah.
Yeah,
Sorry.
Bell Labs.
I'm sorry.
Basically, what happened? The Internet is basically cables being connected. So, companies in each popular country now are going to set up a cable, run into another popular company. And that's how we get networks. So,
So it's like a shark biting the internet.
no, it's possible. It's possible it happens.
Sir, don't act in this.
Somebody could fight me. It was a fiber optic cable. There is a CSEC.
This is what I'm looking for.
Sorry, you got me then.
What? Either way. So you guys seen that, right?
Yeah.
So each of those lines that you see in there is actually a fiber optic cable. Each of those lines is a fiber optic cable. So then somewhere here, we have a cable running somewhere there. And if you notice, North America has how many cables running to Europe, and how many cables. So basically the cables connect to the entire world. So each cable now is going to come from the ISP. What's ISP?
Internet service provider.
Internet service provider. So that's like GT&T, Digicel, E-Networks,
Nobody.
T-Mobile, Verizon.
Xfinity.
Those are all ISPs. And what they're going to do, they're going to set up cables that are going to connect the various ISPs together or connect different locations together. And then they are going to offer services to the small persons like me and you. We connect to the ISP, and the ISP facilitates the backbone connection basically. And that's basically the internet. Huh? Oh, yeah, wider?
Connect two planets together, man. Yeah.
Can't go wider to the internet.
Connect two planets together.
Good. So we also have what is called a wireless LAN, WLAN. A wireless LAN is basically a LAN, but just that it's a wireless version of the LAN. See on? Seems to be distracting everybody. So the LAN is a wired version. So if you see the cables running right now, all those blue cables, that is the Ethernet cable connecting each computer. That is the local area network in this room. The Wi-Fi, SSC, WLAN, IT lab, and so on, that is the wireless LAN. That's the wireless extension of the LAN. Are we clear on all that?
Yes, sir.
Good. Remember I mentioned the term standalone. Standalone refers to a system that is not connected to a network. What do you need to connect to the internet? What do you need to set up a network? You need network cables. You need a network card. The network card is what facilitates plugging the cable into the computer. So most network cards are already built into the computer. So once your computer has an Ethernet port, that is the network card built into the computer. Once your phone, your laptop, your desktop can connect to Wi-Fi, it has what's called a wireless network card inside of it. Hubs, but today what do we use? We use a switch. The older form was a hub, but today we use a switch. If you look at the corner, the back there, you can notice all the cables are connected to a switch.
Yeah, but like none of these laptops are coming also.
Oh, master switch busing coming switch.
So this is what it looks like here. It has multiple ports, which allows you to connect the multiple cables. So all the computers in the room going to have a cable running to the switch, and then one cable from that switch now is going to run to the router that's going to give them internet, or run to the server, which is going to give them connection to the server. Are we clear on that? Nicholas, you with us? Then you need a file server, or basically you need a server on the network that's going to give you files, that's going to give you services on the network. And then you need a system software, because once again, if the hardware does not have system software, you can't do anything, especially connect to the internet. A hub is the central point of connection in a network. So let me give you guys Alright, we gotta work with this here. So, at the top here, you have the internet, right? Anybody got a ruler?
Cloud, right?
So, at the top here, we have the internet, which is represented by a cloud. Anytime you see a cloud, that usually represents the internet. From the internet comes from the ISP, right?
No, sir.
Good. The internet comes from the ISP, right? The internet service provider. So, your internet here, this is represented, say this is GT&T. Now, GT&T is going to run a cable. We're going to call that a telecommunications cable, a phone cable. The technical term is telecommunications cable. So they run a phone cable to your house. The phone cable reaches your house. So just like what you have at home, it's going to reach a gray box, right? Are you following?
Yes.
So from that gray box now, it goes into your home. And it goes to a wall jack in your home, right? And that's where you plug in the landline, right? Now, to get internet, to get the network from the internet, you connect it to a router, right? So, say for over here, we have a Wi-Fi router. So you connect it to, actually that's wrong. You connect it to what first?
The switch.
No,
The line.
no.
Wait, the first thing that went on top of the screen before you put this on,
What?
something software.
No.
The box around the table.
I don't like this diagram anymore.
Babe.
Don't like the box where like teaching before
Sorry,
it
sir.
starts. It's like go back into the text.
What's the device that you connect before your router?
The modem.
The modem. Alright, we can use this one here. So, where you see a router, imagine there's a modem here. So the modem is there because today we have modems, routers built into one. That's why some in our home we got that white device. That's the modem router built into one. So the cable from GT&T connects to your modem. Then if the devices were separate, the cable would connect to the router, which is called your access point. So that term you might see in your paper, access point or wireless access point. It basically refers to the router that gives you your wireless LAN in your home.
It is block.
Yeah. Yes, wireless access point. That's the true definition of it. So, from that cable to your modem to your router, and then from that router now, you could connect a switch, like you see in here. From the router, you connect a switch, and the switch is that device that has multiple ports on it, where you can connect multiple desktops, multiple laptops, and so on with the cable. And you have the router where you can use to connect multiple Wi-Fi devices. So that basic layout you need to remember. And what you also need to note is that the switch, the router, and the modem can be built into one. Can be one device. So they can be separate, all three can be separate, or all three can be in one, or you can have the router and switch in one. That's what some of you have. Yeah.
Is that the special name I put in one or?
We just call them. We still. Huh?
You got a Wi-Fi board.
I don't know. I don't think they gave it a special name as yet. What was I gonna tell you guys?
You got me too.
No.
You know what?
Ready for this meeting?
Ilan, what I tell you?
What are you doing now?
There's something else I was gonna tell you guys about the network.
So we get past tomorrow.
That's tomorrow.
Yeah.
I used to come to school.
Good. So we have what is called, you have what is called a peer-to-peer network. Now, a peer-to-peer network does not have a file server. It's just devices being connected to each other. So, yeah, two guys together.
Hey.
So,
So you. So are you recording by the way?
Why are
sir?
people calling you, sir?
You recorded? It's only you're done recording.
all right. So, a network would normally have a server on it. The purpose of the server is to serve. We have different types of servers. We have file server, we have print server, we have media servers, each functioning as the name implies. They supply files, they supply printing ability, they supply medias and so on, whatever the case may be. So on the network might have that specialized server. Now if a network does not have a server, that is what is called a peer-to-peer network, because there's nobody on the network serving. So each person on the network now is equal, hence peer-to-peer. So now any person on the network has the ability to be the server. So a computer doesn't need to be built big and strong to be called a server. My laptop here could be a server. A server is basically a computer that serves, that gives data, that gives some sort of resource or functionality. So if all of you were to connect to my laptop to download some sort of file, transfer some sort of file, collect some sort of document, use some sort of software, my computer would thus become a server on this peer-to-peer network. Are we clear on that?
Yes.
Now, what are the various forms of network layouts? What are the various forms of a network layout? We have the star network, which basically looks like a star. So the hub or the switch, which is what we use today, the switch is a central device that all other devices are going to be connected to. So all the computers, like what you're seeing right now, all the blue cables run to that central switch. It's called a star. It might not look like a star. The layout might not look like a star, but figuratively, you can imagine it like a star. Next, you have what is called a bus network. It's basically a straight line, a cable running in a straight line, and each device is going to create a branch and connect to that one straight trunk of cable. You understand that? Now, so if a part of the bus is to break,
Everything was
then that means the two will be segregated, right?
strong words.
Now we have what's called a ring, which is basically a ring. It's like a bus, but the two ends are now connected to each other. So once again, if the ring is to break, the network basically goes down because the ring actually goes wrong. The data actually goes around, doesn't reverse. Alright, so we talked about what is a wireless LAN.
I don't buy some. Yeah, going at least.
Did you guys know Wi-Fi is short for wireless fidelity?
Yes, sir.
Fidelity. So, forms of wireless communication, we have Bluetooth, we have Wi-Fi, we have hotspots. So you guys should know what those means, right? Network communication, computers. Alright, here's what. Take a 5-minute break.